Here's a problem chemists face every single day. You want to measure out some carbon atoms, but here's the thing. Atoms are impossibly tiny. You can't see them, can't pick them up with tweezers, can't put them on a scale one by one. So how do you actually count them? That's where something absolutely brilliant comes in. The mole. So chemists invented a clever solution. They said, what if we don't count individual atoms? What if we count them in huge groups? 1 mole is exactly 6.02 times 10 to the 23 particles. That's 600 sextillion. I know that sounds insane, but here's why it's perfect. 1 mole of carbon weighs exactly 12 grams. 1 mole of oxygen weighs exactly 16 grams. See the pattern? The atomic mass number tells you the mass of 1 mole in grams. Now here's where it gets beautiful. This connection isn't random. When scientists defined the mole, they chose that number specifically so that 1 mole of any element would have a mass in grams equal to its atomic mass. Carbon has atomic mass 12. 1 mole weighs 12 grams. Hydrogen has atomic mass 1. 1 mole weighs 1 gram. This transforms chemistry from count 600 sextillion atoms to weigh 12 grams on a scale. You just went from impossible to practical in one brilliant insight. Let's make this real. Imagine you're in a lab and you need exactly 1 mole of sodium for your reaction. Sodium has atomic mass 23. So you grab a scale, measure out 23 grams of sodium, and boom, you have 1 mole. That's 6.02 times 10 to the 23 sodium atoms. Without the mole concept, this would require impossible precision. With it, just weigh something on a regular scale. That's the genius. So let's bring this together. The mole solves an impossible problem. You can't count 600 sextillion atoms by hand. But you can weigh something. The mole is the bridge that converts a number you can measure on a scale into a count of particles you can't see. Atomic mass becomes molar mass, becomes the mass you actually weigh. That's why the mole is one of the most powerful ideas in chemistry. It makes the invisible visible, the uncountable countable. Pretty satisfying, right?